How's it going, you guys? In this video, we're going to be talking about variation, and specifically two kinds of variation. There's more than just two kinds, but we're just going to be talking about direct and inverse variation. So direct variation is kind of like as something goes up, another thing also goes up. So usually, maybe you think about like the more you study, the higher your grade is. For most cases, not everybody, but for most cases, an inverse variation would be like kind of the opposite of that. Essentially, like a situation. The If you're like naturally really good at taking tests or something like that, maybe you don't have to study as much to do well. That's not a very good example. Hang on. Okay, I got it. So like the more you watch TV, usually the lower your grade is because you're spending more time watching TV than you are studying for things getting ready. All right. So with direct variation, notice we have y equals kx. K in both situations is called a constant of variations. Constant of variation. Constant of variation. That's what it's called. So direct is multiplication with the constant. Inverse is when we are dividing by the constant. So what you will see is situations something like this, where it says y varies directly with x. So since I have y varying directly, I know my equation would be y equals k times x because it says it's with x. It also gives me y equals 10 when x is 24. So if I know that y is 10 when x is 24, this helps us to find our k. So if I divide by 24 on both sides, then k is 10 divided by 24. 4.16. So, sorry, 0.4167, sure. So essentially, our equation for this situation would be y equals 0.4167x. So now it'll also go on and say determine the value of y when x equals 40. So I can figure out what my y value is when this x is 40. So if I do 0.4167 times 40, I will get that my y value should be 16.67. That's essentially what variation is. That's how we can mess with it. It's always just messing with these two equations, so it's not too terribly difficult. Another situation you can see if it varies inversely. So now notice it says y varies inversely with a. These are our two variables. So I know y is varying inversely, so I'll put my constant divided by what I am varying inversely with. It also tells me, and it says y equals 15 when x equals 2. That will help us determine our constant of variation. So if y is 15 when, that should say a is 2, k over 2, then that means if you multiply by 2, k is 30. So to figure out, it says then determine the value of y when x is 12. So I'm looking for y when x is 12. So I have 30 divided by 12 since 30 is my k value. 30 divided by 12 is a beautiful number. It is 2.5. So y equals 2.5 when a, should say a is again, when a is 12. All right, moving on. I need some paper for this one, though. I ran out of space. I wrote it too big. I'm sorry. I'm so sorry. All right, paper. Oh, thank you. All right, so it has. Here we have a little bit more. It says a varies directly. So I have variable a varies directly. So I have k with the square of x. So notice it says with the square of x, so I have to take x squared. And inversely, so now I'm dividing by the square root of b. So the square root of b. So that is our equation. And then it goes on, and we can find k by using a is 12 when x is 2 and b is 9. So I have 12 equals k times 2 squared divided by the square root of 9. So in solving this, square root of 9 is 3. So that is 3. So if I multiply by 3 on both sides, then I have 36 equals k times 2 squared is 4k. So that means k is 9 when you divide by 4 on both sides. And then it says determine the value of a when x is 15 and b is 12. So my equation, since k was 9, is 9x squared over the square root of b. Now I need to plug in 15 for x and 12 for b. So I have 9 times 15 squared divided by the square root of 12. Type that in your calculator and you will get that a is 584.567. All right, moving on. So other times you will be given it's really useful to determine how things relate to each other. So in this one, all I'm doing is determining whether the relationship is a direct variation, an inverse variation, or if it's not variation at all. So with these, what I usually like to do is determine the k value, because it's variation only if the k value is the same in both of those. So if I am solving for direct variation, k should be y divided by x, right? Because I'm dividing by x on both sides, so I know my constant variation is y divided by x. That would have to be the same all throughout our table in order for this to be direct variation. If it were inverse, then k is equal to x times y. All right, so here, if I want to check for maybe it's direct, so maybe direct k. So that would mean that k equals y divided by x. So if I take my y value and I divide it by my x value, so negative 2 divided by negative 1 is 2. 2 divided by 1 is 2. 1 divided by 2 is 1/2. Oh no. 1/2 divided by 4 is 1/8. Oh no. So what that tells us, it is not direct variation. So it's not direct variation. Now the other operation that it could be is inverse variation, where k is equal to x times y. So maybe it is inverse. So what is my k if I am inverse? Well, I have x times y, so negative 2 times negative 1 is 2. 2 times 1 is 2. 1 times 2 is 2. 1/2 times 4 is 2. Hey-o, that means it's inverse variation where my k is 2, so my equation, if it asked me to write it, would be 2 divided by x. Cool. Same idea. So I'm going to make a k chart. K. 0 divided by 0 is 0. 3 divided by 1 is 3. 9 divided by 3 is 3. 15 divided by 5 is 3. All right, so that tells us it's not direct variation. Or is it? Because, well, that's 0, but all the rest are the same. They're all changing by 3. So if I wrote my equation, it would be y equals 3x if it were direct variation. Does that make sense for our 0 case? I mean, if I do 3 times 0 for x, does it give me 0 for y? Yeah. Huh, that's cool. So be careful. Sometimes 0 kind of throws things off, but for sure, if you have 0 here, you know it could be some sort of variation. It will not work for inverse variation because any number divided by 0 is just undefined. So this one is direct. This one was inverse. And those are our equations if it asked us. All right, this last one here. Notice this has a y-intercept. So to get any equation, we'd have 15 divided by 0, so we know it's not direct. We have 0 times 15 is 0, that's inverse. 2 times 16 is 32. It's checking for inverse. 4 times 17 is 68. 6 times 18 is a bigger number, it's 108. So that's not inverse. It's not direct, because remember for our direct, it's y divided by x. And if we do 15 divided by 0 right off the bat, that's undefined, so this one will be neither. Also, another way of knowing this, anytime it has a y-intercept, it won't be in either variation. The only time it works with a 0 is actually for a direct variation. All right, last type of problem that you are going to see. Whoa, it takes up the whole screen. All right, so let me zoom out for just a second. Yeah, it's not zooming out. Come on, computer. You can do it. You can do it. There we go. That's a little bit better. All right, so it says the volume of a cube. So the volume of a cube, I'll call that V, varies directly to the side squared. So I will call this side squared. And inversely So directly to side squared and inversely to the diagonal length. I will call this diagonal length L. So I have the volume varies directly to the side squared, so I have ks squared, and inversely to the length. So that's kind of our formula. We do want to find k though to actually state the formula. And it goes on. It says when the volume is 30.5, so 30.5, the side length is 9. So I don't know k, the side length is 9, and the diagonal length is 6. So if I solve this equation, I have 30.5, clear that out. So I have 30.5 times 6, and then I'll have to divide that by 9 squared. So I have 2.259. It's not a pretty number, but that's what our k is, 2.259. So I have my real equation is 2.259 s squared divided by L. Then it goes on, it says determine the volume when the side length is 15, so that is our S, and the diagonal length is 3, that is our L. So you want to know the volume when the side length, so 2.259 times the side length squared divided by the diagonal length, and then just type that number into your calculator. So you have 2.259 times 15 squared, all divided by 3. So our volume should be about 169.425. All right, hopefully this video was helpful. I'll see you guys soon. Bye.